Welcome back to the another metrology and measurements session ME3592. We are on the discussion of the fourth unit, metrology of surfaces. My name is P.NAVIN, JASS, Assistant Professor, Department of Mechanical Engineering, Rohini College of Engineering and Technology. Today we are going to discuss about the direct measurement methods or direct measuring instruments which we are using for the surface measurement, and these instruments are used for used as the stylus based optical measurement techniques. So the direct methods enable to determine a numerical value of the surface finish of any surface. These methods are quantitative analysis methods, and the output is used to operate the recording or indicating instrument. Direct instruments are operated by electrical principles. These instruments are classified into two different types. One type is operated by carrier modulating principle, and the other type is operated by voltage generating principle. In the both types, the output is amplified. So here some of the direct measuring instruments are mentioned here. The first one is stylus probe instrument, and the second one is Thomilson's surface meter, and the third one is profilometer, and the fourth one is Taylor-Hobson-Talley surface. So these are the four direct measuring instruments which is mentioned here. So first we are going to discuss about the stylus probe based instruments. So this stylus is moved over the surface to be measured. The irregularities in the surface texture are measured, and it is used to assess the surface finish of the workpiece. The stylus type instruments consist, some of the units are there. One is skid or shoe. The term named as skid or shoe. It is drawn slowly over the surface. This skid or shoe means it will be drawn over the surface very slowly. The second one is stylus or probe. It moves over the surface with a skid. When the skid is moving, this probe is also moving over the surface of the object. And the third one is amplifying device. This device is magnifying the stylus movement. When the stylus moves over the surface, this amplifying device magnifies or recorded the this device is magnifying the movement of the stylus. And the fourth one is recording device. This recording device work is used to produce a trace. When the stylus and skid moves over the surface, this device is record the trace of the movement of the skid and stylus. The fourth one is output device. This output device analyzes the traces which is produced by the recording device. So here now we are going to see the principle of the stylus probe measurement instrument. This stylus is moved over the surface to be measured. The irregularities in the surface texture are measured, and it is used to assess the surface finish of the workpiece. So now we are going to see the working of this stylus probe instrument. The skid is slowly moved over the surface either by a hand or by a motor drive. The skid follows the irregularities of the surface, provides a datum for the measurements. The stylus moves along the skid. When the stylus moves vertically up and down, the stylus movements are magnified by electronic or optical methods, amplified and recorded to get a trace. Then the trace is analyzed by an automatic device. The vertical magnifications have to be very high to record small values of the order of microns, but the horizontal magnifications have to kept low to limit the length of the graph. So therefore the surface record is obtained as a distorted picture. The main advantage of this stylus probe instrument, which has a desired roughness parameter, can be recorded. So this is the diagram of the stylus probe instrument. This is already I said about the skid, stylus or probe and amplifying device, recording device, output device. So this is that skid and this is that stylus. So when the stylus moves over the surface of the material, the skid also follows this stylus. Now the disadvantages of this stylus probe instrument is the fragile material cannot be measured. This stylus probe instrument can't able to measure the fragile base materials, and this stylus probe instrument is its initial cost is very high, and we need a skilled operators to operate this stylus probe instrument. Then next one is Tomlinson surface meter. Tomlinson surface meter. Here I am going to discuss about this Tomlinson surface meter. This instrument uses mechanical cum optical means for magnification. So here the Tomlinson surface meter recorded the traces with the help of diamond scriber, which is in the Tomlinson surface meter, and the scriber scratches the glass or smoked glass when the skid and probe which moves over the surface. If there is any deviation on the surface, this probe indicates the diamond scriber to mark a trace on the optical glass or smoked glass. So now we are going to discuss about the principle of this Tomlinson surface meter. The stylus movement is restricted in the vertical direction only with the help of coil and leaf spring. So in this, stylus is restricted to the movement of vertical movement or vertical direction with the help of a coil spring, which is on the top of the scriber handle, and the variation in the surface is sensed by the probe and it is magnified on a smoked glass. So this probe is sensed the variation on the surface and it indicates the diamond scriber to mark a trace on the smoked glass. So first of all, we are going to see the construction which is on the Tomlinson surface meter. The diamond stylus or probe on the surface finished recorder is held by a spring pressure against the surface of a lapped cylinder. The tip of the diamond probe has a radius of 2 micron. The lapped cylinder is supported one side by a a stylus and the other side by rollers. The stylus is also attached to the body of the instrument by a leaf spring, and its height is adjustable to enable the diamond probe to be positioned. The stylus is restrained from all motions except the vertical one by the tensions in coil and leaf spring. The light spring steel arm or lever is attached to the lapped steel cylinder. The spring arm carries a diamond scriber at the end which stands against the smoked glass. So the main advantage of this Tomlinson surface meter is it's an very simple in construction. It has comparatively cheaper. It gives reliable results. And some of the disadvantages also in this Tomlinson surface meter: it is delicate and requires great care. The operation of this Tomlinson surface meter is very slow, and it is not suitable for rapid and continuous use on the shop floor. Then the third instrument is profilometer. It is an indicating and recording instrument to measure roughness in microns. The main parts of the instrument are tracer and an amplifier. So in the figure, it shows the profilometer. The main parts are in the profilometer is stylus or probe, and the springs which is to hold the stylus or probe, and the magnets are on the top of the profilometer and also with indication coil. So here the working of this profilometer: when the stylus moved on the surface to be tested, it will be displayed up and down due to irregularities in the surface. This movement induces the induction coil to move in the direction of the permanent magnet, and it produces a voltage. It is amplified further and operates an indicating device or recorder. So this is the working of the profilometer. And next one is Taylor-Hobson tally surface. Taylor-Hobson tally surface. So this Taylor-Hobson tally surface is an electronic instrument working on carrier modulating principle. It is an accurate method as compared to the other methods. Previously we saw three methods. This Taylor-Hobson tally surface is very good compared with the other previous methods. The principle of the Taylor-Hobson tally surface: the irregularities of the surface are traced by the stylus which is attached to the armature. Here we are going to see the construction of this Taylor-Hobson tally surface. So the outer casing, the skid which is on the left of this casing, and there is a probe which is connected with the armature, and this armature which is connected with the E-shaped stamping frame with a conduction of coils. Now when we are going to measure the surface of the material, this probe which moves over the surface, when the probe which is moved over the surface, if there is any deviation, it indicates the armature or E-shaped stamping frame with the help of the armature, and it indicates the device to show the output value. These are the things we discussed. So these are the things we discussed in this topic of direct measurement methods or quantitative methods. So by this topic we are concluding this session. We are going to join the next section related to this unit, so be prepared for the next topic. Thank you.